So we're going to actually solve these examples now. So, number 1. Again, pause, try it on your own, and then press play again. So the common denominator is 60x. So what I'm going to do is multiply both sides by 60x and distribute it through. So that we get 60x over 5x minus 60x over 4x plus 60x over 3x equals negative 17 times 60x over 60. Now we're going to simplify. Let's see. The x's reduce out for all of these terms, all 3 of those. 60 divided by 5 is 12. 60 divided by 4 is what? 15. I always think of a clock. 60 divided by 3 is 20. And then over here, it's actually the 60s that are going to revert, that are going to reduce. And we're just left with negative 17x. So now we have a linear function. Back to the examples that we talked about a page ago, a couple of videos ago. All right, so now let's see. Well, 20 minus 15 is 5. 5 plus 12 is 17. So we've got 17 equals negative 17. Divide the negative 17 over. So x is equal to negative 1. And then typically you would toss in negative 1 to check. So I want you to do that on your own. Toss in negative 1 into x to make sure that you do indeed get negative 17 over 60 equals negative 17 over 60. And then the last step, check to see, is that the number we don't want? See, the number we didn't want is 0. That we've got negative 1, so we are good to go. Okay, number 2. So, here, like I said, we already talked about how it already has the common denominator of x minus 4. So, if I multiply both sides by x minus 4 and x minus 4, what we end up getting, let me change colors, is x minus 4 over 2x minus 3 all over x minus 4 equals 5 times x minus 4 all over x minus 4s. So what happens to all the x minus 4s? They just reduce. And we're left with just that linear version again, 2x minus 3 equals 5. So now add the 3, 2x equals 8, divide the 2, x is equal to 4. But look at the breadcrumb. That's the one number that we actually did not want. So if the answer is actually the only number we can't get, then what the heck's the answer? What do you think? No solution. No solution. So again, that's the empty brace or that 0 with the line through it, right? So no solution. Because remember, 4 is the one number that we could not have. Okay, and then, so for 3, we're actually going to be a little tricky here for 3. I've got t over t plus 3 plus, now for 4, I'm going to multiply in by a special version of 1. So let's talk about how and why this is allowable. So, what's anything over itself? 1. What's 1 times anything? The thing, right? So we're not actually adding in any weight or value to the problem, so that's why adding in versions of 1 are so nice in math, because it's a way to manipulate and kind of like trick the system of what's actually happening. So now, as you can see, every single term has a common denominator of t plus 3. So it's kind of a combination of what we did for 2. So you would also multiply everything through by t plus 3. They cancel out, blah, blah, blah. So we're just left with t plus 4 times t plus 3 equals 2. Now we're going to distribute that 4 to get those parentheses to drop out. T plus 4t plus 12 equals 2. Now remember, what the heck is the whole point of this again? To solve, right? So we're going to hopefully get eventually t equals. So t plus 4t is 5t plus 12 equals 2. We're going to subtract the 12t from both sides. So I get 5t equals, negative 10. So t equals negative 2. Is negative 2 a viable answer? Yeah, right? Because the only answer we didn't actually want was negative 3. So our answer now is negative 2. All right, last up is 4. So 4, we're another kind of technique manipulation that we have to discuss. So the common denominator for 4 is actually 2w minus 2. Right? The common denominator is 2w minus 2. So how do I get this first term to get that denominator? Well, like I mentioned with 3, we are going to use that special form of 1, but only for this first term, right? So now I've got 2 over, I'm going to distribute the 2, 2w minus 2 minus 1 over 2w minus 2 equals 1 over 2w minus 2. We have our breadcrumbs, so we know that we cannot get an answer of 1. And now we can just simplify. So going off of what we talked about with 2 and 3, so you can rewind to 2 to remember how to get rid of the denominator. So realistically, we just have 2 minus 1 equals 1. 2 minus 1 is 1, which equals 1. So this is an identity, but I'm going to say almost. Because does 1 equal 1? Yep, sure does. But remember, this was rational. Remember, the rationals we can't divide by 0. So we have every number except 1, right? So we want every number except 1. So I'm going to have negative infinity to 1, union 1 to infinity. So this, remember this is interval notation. Watch the homework to see what kind of notation solution they want, if they want set or interval. Typically, if it's a number, right, remember that's conditional, they want the number. If it's something like this, they'll want interval. So this says, like, as a number line, if this is 1, open circle here, and then everything else is filled out. So every number but 1 works. Pretty cool, right? So to go through, to hit home, because some of your homework is just not what's the answer, but what kind or type of solution did we get. Here for 1, we have conditional. Here for 2, we have contradiction. For 3, we've got conditional again. And for 4, we've got identity, right, but with that kind of exception attached to it.